Hello guys, let's talk about part 3 of UPSC ESE exam previous year's question. In part 2 we have discussed a few questions from the year 2018. Now we shall be discussing furthermore questions. We have this question over here, question number 6, that was asked in the year 2018 of ESE prelims. This question is based on source transformation over here. Okay, here I1, I2 and I3 are question marks. Okay, we need to find out these currents. This exact question I have solved in my previous video, so make sure you check that out. For the time being, we have applied KCL at these two nodes. So on applying KCL we get these two equations. Then we perform source transformation because we are having a resistance in parallel to a current source, a clear indication that we can apply source transformation, and it is nowhere mentioned that the sources are ideal, so we can apply source transformation. On applying source transformation, your circuit is converted from this over here to this. Okay, then we calculate the value of I2 by total voltage upon total resistance, and when you get the value of I2, you put this I2 in these two equations to get your I1 and I3. Now we are moving forward to the next question of the year 2018 itself, which is, this is your circuit given to you and they are asking the value of this R over here for the value of I is 4 ampere. Okay, now we are going to apply mesh analysis over here. It is pretty simple. It is easier to write mesh equations than nodal equations. So this is your basic voltage equals to this voltage over here is actually giving rise to this current and this resistance, this current and this resistance, this current and this resistance. So what we are doing, we are applying KVL over here. In mesh analysis we do the KVL, in nodal analysis we do the KCL. Okay, so this is the mesh analysis over here. On solving this, you get voltage across 14 ohm resistance. Okay, this is how, because this voltage over here is this voltage and this voltage is also this voltage. So when you know the value of voltage and you know the value of current, then you can easily calculate resistance. So this question was pretty easy. Now we shall be discussing further questions. Now this question over here is regarding LC circuits. Okay, and I have not completed the notes regarding series, parallel, RC, RL circuits. So when I will complete those notes, I will once again move to these questions and explain it in detail. Okay, but for the time being, the question is, the VI characteristics are given and you need to identify whether the element is a capacitor or a inductor. Okay, and the value of the same. Okay, so as per the graphs over here, as per the VI characteristics, we know that this is an inductor. Okay, this is the VI characteristics of an inductor. So what we do, first we calculate the value of VT and then we put it into the formula, this one over here. Okay, and then we find out the value of inductor. Now we are moving forward to the questions from the year 2017. Okay, one first question over here, it is again from the source transformation, same question as it is but they are asking the value of current through this 5 ohm resistance only. Okay, not all the currents but only this current which is passing through this 5 ohm resistance. So what we are going to do is, we are going to apply source transformation because we are given a resistance in parallel to a current source, a clear indication that we can apply source transformation. Besides, it is nowhere mentioned that the sources are ideal. So let's move forward. Your circuit, this one is converted to this circuit, and then you can apply total voltage upon total resistance and you get the value of your current. Now we are going to have some theoretical questions over here. What is satisfied in a non-linear network? This is the question which is based on my first sheet and I shall be linking that sheet in the description box. KCL is applicable to closed loops in a circuit, junctions in a circuit, magnetic circuit, so on and so forth. So the answer is junction in a circuit. Okay. KCL is always applied on junction. And what is satisfied in a non-linear network? You know, for a linear network, homogeneity and superposition, these two are mandatory. Okay, for a linear circuit. So for non-linear, the answer would be 1 and 4. Now we have the next question over here, which is, what is the voltage drop across this 80 ohm resistance? Okay, this is your circuit and they are asking the total voltage drop. So what we are going to do is, these two resistances together will draw current from this source over here. So we find out the value of current using the Ohm's law, the supply upon total resistance, which will give you total current, and then the current passing through this resistance will give you the voltage drop across this resistance. Okay, so it will be V equals to IR, and this would be your answer. This is pretty basic question, nothing to be worried about. The next question again we are having from the year 2017 is this is your given circuit and they are asking what is the value of current passing through this 8 ohm resistance over here. Okay, and the direction of the current as well, whether it is from M to N or N to M, whatever it is. So these are your options. Now what we are going to do is we are going to apply nodal analysis, and if you have some worries regarding nodal analysis, I will be mentioning the video of nodal analysis as well in the description box, so make sure you check the description box over here. Now what we are going to do is we are applying basic nodal analysis. This is your reference node with a reference voltage V0, and this is your ground. Now we are moving from V0 to this over here, your voltage source, and you meet with a negative sign, so we will write positive. It will be V0 plus 8. Upon the resistance you meet midway, so this is 12. Now we are doing the same thing over here. Since this is connected to ground, it will be V0 minus 0 upon 8. Okay, and this one would be V0 plus 2 upon 8. Okay, on solving this you get the value of your reference voltage as minus 11 by 4 volts, and the value of resistance you get it. So now this is all for part 3.